Alrighty, folks. So today we're going to be talking about section 2.3. So it's the last of our sections that are focused on the whole gathering and displaying data. And for next chapter, we'll be dealing a little bit with describing data. So that we can get to the business of analyzing it, right? We have to be able to describe it in some specific ways to talk about analyzing it. And that's what we'll get into next time. But for here, we're just going to wrap up some odds and ends about graphs. So the first section, or the first part of this section, really comes down to some things to look at to not be lied to by pictures in the newspaper. Right, so things to be careful about. Or really, for us, let's say careful too, since we're the one making these graphs, presumably. We want to make sure that there are good labels. And really, we're going to be talking about how pretty much all the pictures that I drew last time, while they might be good, vague representations of what that kind of graph looks like, they're horrible graphs on their own. Right? So just doing this and plopping some stuff down, what is this about? Nobody knows. Right? We need to know what classes are. And for the heights. Right? What does this mean? What does this mean? What does this mean? If you're doing frequencies, you want it to start at 0. That's really something else. We want to make sure that we scale things properly. Right, so we talked a little bit about that when we were talking about making frequency distributions. We want each class should be the same width. Right, because otherwise if you have two different classes and one of them is wider than the other, then the wider one's going to look like it has more in it. Even if what really matters is the height, it's going to trick the eye into thinking that the wider one has more in it. So each class, which for a bar graph would be a rectangle, for our, well, really for most of them it'll be rectangles when we're talking about scaling. Also, the y-axis, which is this one here, the height axis, the y-axis should start at 0. Right, and there's a picture that I've seen going around on Facebook, so folks might have seen it. I'm going to do a very bad job of copying it. Right, so if we have like 5 foot 5 inches and 5 foot 7 inches and 5 foot 9 inches and 5 foot 11 inches, right? If this is it, so we clearly didn't start at 0. We started at like 5 foot 3 inches here, right? But maybe we didn't put that there, right? Maybe we didn't leave it in, right? If we're comparing people, say there was someone whose average height, or some group whose average height was 5 foot 5 inches, and some group whose average height was 5 foot 9 inches, well, that looks ridiculous, right? It looks like that this group is 3 times taller than this group on average, and that's not right. It's 4 inches taller on average. So the fact that they started their scale, they put the feet of these pictures down at 5 foot 3, means that all those differences are just magnified to a ridiculous extent, right? If they'd started way down here at 5'3", then there would only be a small representative difference in those two things' height, rather than looking like it's 3 times as tall. So that's a fairly important thing, right? So this is another bad graph. You need to make sure you have a source for your data. If a bar graph doesn't have where its data came from, there's no way to tell whether the samples were done properly. There's no way to tell what actual population they were looking at. And it's really a whole lot of questionable behavior if you can't look back into where that data came from. And often, this is going to come along with date it as well. Right, especially if you're doing a cross-sectional study, which remember we talked about last time is kind of like when there's a, you're taking a snapshot, you're looking at things at a particular point in time, then you're really going to want to know when that snapshot was taken, right? If you have a bar graph about things, and your data was from 20 years ago, then it doesn't really matter what you're measuring in that bar graph. It's probably changed at least a little bit. So the date given with a particular graph is also very important. So the other things to consider, we mostly talked about it last time, but you want to choose the appropriate type of graph, right? So if it's not nominal, you don't want to choose a Pareto graph. If it's longitudinal, you probably want to use a line graph. If it's cross-sectional, you probably don't want to choose a line graph. So you want to choose the correct type. And that's about what we have. One thing that I possibly should, well, they make a deal about it, putting it sort of separate. Using pictures to make your graph all cute is all well and good. Like, the fact that I drew stick figures here is not the problem. The problem is where my graph started, right? And drawing stick figures is perfectly fine as long as you draw them to scale, right? So it's really, when they're talking about the pictographs in your book, it's really just another way of talking about having it scale properly. So those are best practices to do on your own graphs. They're also best practices to look for when you're looking at someone else's graphs, right? If you're looking at graphs in a newspaper or on an article somewhere, then you'll want to make sure that they've labeled things appropriately and you know exactly what each of those bars is representing, and you'll need to know that they started their y-axis, they started the height part of it at 0, and you're not actually looking at utter giants who are 5'9". You'll want to know where that data comes from, and that sort of thing. So that's the first half of this section. The second half of this section talks about shapes. And so this is most of the examples they use are, I guess they use one bar graph and then they use histograms. We're going to be looking at a lot more histograms than bar graphs because, again, we like our quantitative data here in math when we want to actually, do algebra to stuff. So, but when you talk about the shape of a graph, we're kind of thinking of drawing a line through things. So let me draw some pictures here. I'll actually change this one and have it go all the way up to there. Forget about that. And one last example, because there's 4 shapes that we talk about in this section. And we're going to pretend like all these have the same width, because I'm just not that good at drawing rectangles, apparently. So we can look at it this way. We can also draw, oops, that's not what I want. I want that. We can also draw lines. Sort of, the idea is it's going through the top of that thing. Right, so those are sort of our shape lines. But really we just need the bars. Right, so one thing we kind of notice about this one is that it's sort of symmetrical. It goes up and down. It has roughly the same amount on each side. Not perfect, but roughly. And this one, that's where it gets its name from. That first word that I described it at is symmetric, right? You might have also heard the bell curve. This is the thing, if you're familiar with a really pretty wretched book, this is the thing it's based off of. That book didn't name it. But it's sort of named after this shape, right? That's sort of the perfect bell curve. And if graphs sort of kind of look like it, then we call it that. The down here, right, my orange line got a little wiggly, but these kind of look like they're straight across, right? There's some little variations, but for the most part, it's uniformly flat. Whoops. So we just call it uniform, right? So sort of the ideal shape would be just going straight across, but we can have a little bit of wiggling, right? So these two are both called skew, right? And this one is skew left, and this one is skew right, right? So skew is a word that's in English as well, and it means pretty much the same thing in math as it does there. The key thing to remember is it's one where you have a sort of flatter tail, and then it goes up to a higher peak, right? Or maybe it starts at a higher peak and then goes down to a flatter tail. And this left or right always refers to the tail, right? So sort of a perfect skew left would be this guy, and a perfect skew right would be this guy. So it's still got that generally bell curve-ish shape, except more of it has been shoved to the right or to the left, right? And it's named after the side that it's been shoved away from. I know that it has never stuck particularly well in my mind. I always have to look it up and remind myself which one is which, but maybe I'll eventually remember that it's the tail that determines where it's skewed to. So that's what we have for shapes here, right? These 3 shapes, and sometimes like it can be hard to tell between a skew and a symmetric, but it's another one of those things that comes with practice and getting used to it, and being comfortable with that sort of pattern matching. So it's another place where the homeworks, where recall homework is based on mastery, so you get all the time that you practice that you want, that gives you that chance to just work through a whole bunch of them, and figure out how to sort of tell the difference between symmetric and skew. So that's going to be it for our discussion of graphs. Next time we'll be starting chapter 3, which is where we're going to start to talk about not pictorial descriptions, but numeric descriptions. So different ways of measuring and summarizing data using numbers, which is going to be our first step towards analyzing this data that we get. So I will see y'all next time.